All right. Welcome back, everyone. Good to see you again this Saturday morning or evening, wherever you are. So, the goals of this lesson is called Basic Natural Language Processing. So, I have two main goals for this lesson. One is I want you to understand the field of natural language processing at a high level, and some of the basic terminology, some of the basic task areas and components. So I want you to recognize those and see kind of the scope of natural language processing so that when you talk about NLP, you know what you're talking about. You may already, but if you don't, I want to give you those tools. And second, I want to help you master really simple NLP techniques in scikit-learn that will help with machine learning. So we're specifically going to focus on simple NLP techniques in this lesson, but in general. And why are we going to just focus on the simple things? Well, the complex things would take a long time to learn. And simple, the kind of rule in machine learning with text is simple goes a long way. So you don't actually need to get that complex to accomplish machine learning goals. So that's one reason we're going to focus on simple. Why are we doing this in scikit-learn versus NLTK or Spacey or anything else? So my philosophy is that it's best to master a small number of tools, especially if they're really good tools. So scikit-learn, excellent tool, worth going deep in and doing as much as possible in scikit-learn, rather than getting okay at that and then getting okay at NLTK and then trying to stitch them together. So again, we're going to talk about simple NLP techniques, specifically ones that help with machine learning. Okay, and that'll make more sense after I kind of introduce NLP and its scope. Okay, so those are my goals for the lesson. And now let me just, I've got this notebook open, O2 Basic NLP, and this first part is just, there's no code, it's just an overview. So first I just want to talk about what is natural language processing. So the best definition I could come up with, or from other sources, in one sentence is NLP is using computers to process, meaning analyze, understand, or generate natural human languages. Okay? So pretty broad scope. Now, why do we care about NLP? Well, most data out there, or most things that could be considered data, a lot of it is unstructured text, not numbers. But we need a way to make sense of it. As you saw last time, we use Count Vectorizer because we need to take this unstructured text and give it some structure by counting words. So lots of text out there, and we need a way to make sense of it. Okay. So how does NLP work in a sentence? Well, you build probabilistic models using data about a language. Okay. So first, that means you do different things depending upon the language. NLP is not you figure out one system and apply it to all languages, because it doesn't work like that. So you need to understand each language that you're going to work with. And when I say build a probabilistic model, I don't mean like a machine learning model necessarily. Here's the best example I could think of. There's a task in natural language processing called named entity recognition, and what it basically means is when you have text, you might want to be able to pick out the names of people and organizations and locations. Why? Because if it's, especially if it's multiple words, it's like the subject. You can imagine a search query. It's useful to figure out, what are the named entities in that query, because then I can search for those things as a unit. Anyway, What would be the probabilistic model that might help us with that task? Well, you could imagine that you could say like this: if it's a lowercase word, the probability it's a named entity is 5%. If it's an uppercase word, it's 30%. If it's two uppercase words next to one another, it's 60%. If it was two uppercase words after a preposition, maybe it's 80%. So I'm just making that up. But the point there is we have a goal, one very specific goal, which is identify named entities. And how we do that is we build a probabilistic model that looks at the language, and based on an understanding of the language, it says, oh, well, knowing that the letters are capitalized and the part of speech of the words around it is a good indicator of how we can predict, if you will, whether something's a named entity. Okay, so that was kind of a long example, but the point is we're building probabilistic models in natural language processing. Okay, now, as you can see from the example, that requires an understanding of the language and of the world in general. And by that, I mean you have to understand how people use language, have to understand idioms and sarcasm and ambiguity that's present. So it's more than just gathering data. It does actually require an understanding of language. Okay, so that's just some really high-level information about NLP. And let me pause there. Amir asked, what exactly is unstructured text? Okay, so most text I would consider unstructured. So unstructured text is basically like regular text to which a useful structure has not already been added. And maybe to my knowledge, there's no formal definition, but you might say that the body of an email message is unstructured, but the header is structured text because you've got a from, like it's been labeled as the from field is the person it's from, and it's a name and an email address. The IP address that it came from is just, you could say that's text. It's kind of text anyway. So its structure has been added that's useful to your task. I guess that's the definition of structured text. But most text I would consider unstructured. Hope that's helpful. I can try to come up with more examples later if that would be useful. Okay. That's some high level at NLP, and I want to talk about some task areas to give you more, understand the scope of NLP. And for each task area, I will just name it and then describe it briefly and give you an example, and then we'll kind of move on from there. So what's one? Information retrieval. So that is the finding of relevant results and similar results. So when you type a query into a search engine, you are asking it to retrieve information about that topic, maybe find results similar to those pages that you found useful, etc. Okay? Information extraction. So that is getting unstructured documents and extracting structured information that is of use to you. Okay, so one example of this is if you're a Gmail user, you might have noticed that if someone sends you an email with a date and a time of a meeting, maybe Gmail will highlight it and you can click on it and add to your calendar. So it is figuring out how to detect dates and times and even I think the subject of the meeting, if you will, from an unstructured email. So it's seeing, oh, that's probably a date and time. Let me pull that out for the user. Okay. Machine translation, pretty obvious. It's just translating one language to another. Text simplification, it's not talked about very much that I notice, but it's about preserving the meaning of text, but simplifying the grammar and the vocabulary. The goal there is very often to help people learning a new language. Okay, so try to preserve the meaning, but simplify the grammar and the vocabulary. Rewordify, and all of these are clickable links if you didn't notice. Rewordify is this tool you can use that you put in complicated text and it spits out the simplest equivalent. Simple English Wikipedia is a version of Wikipedia that is written with simple English. I don't think they use any automated natural language processing to do it, but that's the goal. It's providing the same information in a simpler way. Okay, predictive text input. So you see this all the time if you do text messaging on your phone. You start typing something and it does prediction. I've actually built a very simple application that does this. And if you click this link that says My Application, it will open this and it will take a minute to load. And even if after you think it's loaded, you'll just have to wait another minute. But I'll show it to you. And I'll actually, if we have time at the end of class, I'll show you how this works. But it's kind of fun. And I can talk about how I built it. But basically, you enter, it doesn't try to autocomplete your words, it just tries to guess the next word. So if you enter, I'm going to the, it guesses I'm going to the game, and I'll just make up some stuff. How are you celebrating? Okay, you could play around with this for a while. It's not amazing, but it works okay. And I'll talk at the end about how I built it. This second link is to it's like the same concept, but much executed in a much nicer way. So that one is actually really nice. Okay. Sentiment analysis. If you've heard that term, that is about detecting the attitude of a speaker. And this is just a little app I found that allows you to plug in someone's Hacker News name or Twitter username or something, and it will tell you how hateful they are. So that's just, hate, it's a strong word, but basically how negative are they or positive are they in what they say. Okay. Another task area is automatic summarization. So there are two types of summarization. So summarization first is taking, let's say, an article and summarizing it. What is it about? Extractive summarization just pulls out what it thinks are the key sentences. Abstractive summarization is actually about rewriting. It's using sentences to summarize it that weren't actually in the article as it started. Okay. So this is a cool example. There's something on Reddit, might not be functional anymore, but it's called Auto TLDR. And I just pulled out one example, and you can look at what it does and the source article, and it's relatively impressive what it's doing. And we'll do something like that in the next class. Okay, just a couple more task areas. Natural language generation. So this is about taking data and generating text from it. And these are two really fun articles. One is about a computer system that automatically writes news articles about sports events so that newspapers can write those articles without hiring a reporter to watch the game or to write anything about it. That's a really nice article. And this is a fun one. Publishers withdraw more than 120 gibberish papers. That, especially if you're in academia, this is about this person who made a system that would create fake papers, meaning like they're kind of nonsense, and then it submits them, I think, to journals and tries to get them published. So really, that's kind of a fun one. Okay, speech recognition and generation. That's like your typical taking your speech and converting it to text, taking text and converting it to speech. And then finally, one of the most famous NLP examples is question answering, specifically IBM's Watson. If you remember, Watson beat the Jeopardy champion, Ken Jennings. And here's some good articles about that. The AI behind Watson is really long, but has lots of details on like how that works. So that's really, these are some high level tasks that you might have heard about, and I wanted to give you some understanding, some basic understanding of what it's about. Okay. But let me say this. You don't, if you're working in NLP, you don't just say, hey, let's just do some question answering, okay? Or let's do some natural language generation. That's not your starting point, or it might be your overarching goal, but that's not like a discrete task. Each of these higher level task areas I've been talking about is broken into a lot of more discrete, smaller components that you use to accomplish these higher level goals. So these are some of the what I'm calling lower level components that are used to execute these higher level tasks. Okay. So some components, tokenization, and we're going to cover a few of these in practical terms, like we're actually going to do them. Tokenization, we've already seen. It's about breaking text into tokens, meaning words or sentences or n-grams, which we'll talk about later today. It's stop word removal, which is removing common words from your text. It's TF-IDF, which is about computing word importance, and we'll go through that next week. Stemming and lemmatization is how you reduce words to their base form. So removing, like, if I have the word stemming, I would reduce it to just stem, perhaps. Okay. Part of speech tagging, that's just tagging words with their parts of speech. I've talked about named entity recognition. Segmentation is about how you decide what components of a phrase belong together. So if someone writes New York City subway, are they talking about a subway in New York City? Or are they talking about a new subway in York City? Or are they talking about a city subway, where city is a descriptor of subway that is located in New York? How do you determine that? So that's segmentation, okay? Word sense disambiguation is basically, if you type buy a mouse into Google, it's going to show you how to buy a computer mouse. It's probably not going to show you how to buy a live mouse. I mean, maybe if you click to the second or third pages, it might. But how does a computer decide what you mean? Okay. Spelling correction, it's another component. Language detection. And then finally, machine learning. So I want to just say for a moment that natural language processing is not equivalent to machine learning with text. And what I mean by that is they have very different goals, okay, and ways of going about their business. Natural language processing, as I mentioned, is about analyzing, understanding, and generating natural human languages. That is a very different goal than machine learning, which is, if you're talking supervised machine learning, you're building predictive models. If you're doing unsupervised machine learning, you are trying to extract the structure from data. The fact that text is the input data doesn't make it natural language processing. You may have some of the same goals if you're doing machine learning with text, but machine learning is more like a little component that is useful for the much broader field, well, broad in a different way, the broad field of natural language processing. So machine learning is just a tool in the natural language processing arsenal, if you will, okay? So it's a very powerful and helpful tool, but machine learning with text is not the same as natural language processing.